Hi, I'm Jeremy, and just a couple of days ago, I published an article called The High Compression Deception, a reality check on historians versus open source databases. And I thought, okay, reading those super long articles might not be for everyone, so I thought I create a small video about it and basically go through the general content and the general ideas very quickly. So this article is a follow-up article to a previous ones called Historians versus Open Source Databases, which is better, where we drew parallels between InfluxDB, TimescaleDB, and historians. And what we established there was that you can use the United Manufacturing Hub as a potential bridge to bridge the gaps that you have in the current fields of historians. So what happened in the article, historians, they're very good for OT people, but they're very bad to integrate into modern landscapes, no Docker, etc. But IT databases, such as an open source database, is very good to integrate. Cloud, it can really scale very well, but it's hard to use for OT engineer when he needs to spawn up his SQL commands and suddenly write SQL commands. And one of the follow-up questions we got was, okay, very nice, but how does it compare? So how do open source databases compare in terms of compression? Because if you take a look at the numbers, they have like absolutely absurd amount of high compression rate, something which open source databases, they never provide. They only provide you like 95%. And if you take a look there, it's like 99.9997% compression rates. And this is one question that threw me into a rabbit hole, where I spent way too much time again. And I actually got some interesting insights. So the first one is that I thought about, and this point actually came from Rick Bolata, so thank him for that. What is the business case? So in general, you always need to think about, okay, why are we doing compression at all? Why do you need it? And if you take a look at the modern time where storage costs are dropping rapidly, is compression really a thing? I did a small calculation here, basically saying, okay, what happens if there is an OPC-UA server with 30,000 data points, assuming it's an energy reactor, you fetch it every second, so all 30,000 data points every second, something that really doesn't happen because most OPC-UA servers fail at that point, but it would generate around 3.7 terabytes of data annually, which results in 37 terabytes over 10 years. 10 years because most industries that are regulated, they need to store it for 10 years for regulatory purposes. So I just took 10 years. If you take this and just store it in a cloud-based S3 bucket, here an example I took AWS, it costs $850 per month. If you now apply like a standard IT lossless compression algorithm, this even goes down to $50 per month. So $50 per month to store all the data from that energy reactor. It is really cheap. If you now compare it, and there's a proposal, can open it here. It's a public made a proposal from Eyes of Pi, and interesting. I'm just seeing it. The guy who was where it was written to was called Jeremy as well. Nice. But it cost like $120,000, and so $100,000 one-time fee just for 10,000 tags plus a 15K annual maintenance fee. If we now start to compare it, the previous example was with 30,000 data points. If we compare it, then we know that the software maintenance of alone, yet only the software maintenance of Eyes of Pi is roughly 100 times more expensive than the S3 storage. And even if we don't even consider the one-time cost, the personal, the training, and everything else. So of course it's not really that fair because like historians provide much more information, much more than that. But if you just have a historian for to store data for regulatory purposes, you're throwing money out of the window. It's an absolutely difference between paying, it's not even sunk cost, because alone the annual maintenance fee is 100 times more expensive than if you would just send it into a S3 bucket. I mentioned these high compression rates, and one thing that was really interesting, and that was the original goal of the article here, was to see, okay, but how do they do this? And they do a trick, and this is kind of a difference between IT and OT. In IT, compression typically refers to lossless compression, so you don't lose any information. In OT, it also means downsampling. So what typically is done is you combine, to achieve these high compression rates, you combine exception reporting with a compression algorithm. So exception reporting means basically before the data, this example is now for size of pi, or currently called Aviva Pi. Who knows where it's, maybe it's called in the next couple of years Schneider Electric Pi, who knows. Before it's transmitted to the Pi server, only if the value has changed, it will be sent to the server. And sometimes even you apply a deadband, so only if the value has changed significantly over the instrument's precision, you will send it to the server. And then when it's there in the server, the swinging door algorithm, it's called like this, please don't ask me why, is applied, where it's, I don't want to go into the details, there's a video here from Aviva Pi which explains it much more in details, but basically before it stores it, it applies an algorithm based on the last data points. In some industries, such as pharmaceuticals, it's not allowed to do it. So what you only do is you only apply the lossless compressions there. This was like how they achieve it. So they actually downsample the data. If you ask someone in IT, if you just give them the word, yeah, first downsample the data, then compress it, they will be able to achieve similar compression rates. So what are the other reasons to use historians? Because they deliver much more. We spent a lot of time already in the last article, so here I only want to summarize summarize it a little bit. So, a historian has all types of capabilities, from data collection, contextualization to visualization, and they're all customized and tailored to manufacturing and bundled together. But if you take it, they have let's say 10 tools in it, but each of these 10 tools, if you compare them to professional tools just dedicated for the single task, they often fall short. So for example, taking a look at visualization, tools like Grafana or Microsoft Power BI, it tends to have more capabilities than a PyVision or PyData link. But it might not be perfectly usable for the OT engineer. So it doesn't speak exactly the same language, but in general, I would say it has more functionalities. Cost of data storage, we already talked about it. And I already mentioned it previously, it's hard, you cannot integrate a historian into a Kubernetes cloud-based architecture. It's not even deployable as Docker containers. It's hard to monitor with something like Prometheus. It's very often they only run on Windows, which it was fine 10, 20 years back, but now the modern infrastructure is really difficult. Also, if you now think about okay, but historians they're GXP compliant and etc. Rest assured, AWS, Azure, Google, I linked articles here, they're also all GXP compliant. And I would say fun fact for this compliance stuff, it's only in very rare cases, it's very concrete specifications. It's mostly about convincing the auditor to put a signature under it. And there are no really fixed elements in it. In the last article, I already discussed it. If you would consider what the historians are doing at the moment, to what's written in the regulatory statements. If you would give it an IT person, he would probably say, or at least I would say, in my opinion, that it would not be compliant. So, but because it has been used since the 80s, all the auditors feel comfortable because all hundreds and thousands of people before it have signed off on it. So, fun fact. So if we summarize it all, the only reason left for using an historian is if you want to gather, contextualize, and store data without doing anything more, and you don't want to worry about maintenance or setting up your own systems. You just want to buy something and be done with it. And this additionally comes with monetary cost. But now to think a little bit into the future, if you want to do more than that, if you want to think about like IT-OT convergence, unified namespace, sending data to the cloud, real-time AI analysis, you will find very, very quickly the limitations of traditional data historians. So how can one do it? I already said like one of the words, unified namespace. So you don't have to, and you really shouldn't throw out historians. It's really not helpful for digital transformation to like rip and replace and creating discontent among stakeholders. You shouldn't do that. But we already talked about this. If you build up on technology of the 80s to 90s, there are technical constraints. So what you can do is you can start building a new foundation architecture in parallel or together with the current existing one. This is the one that most companies do. If you're planning a new factory, I would recommend you to not use an historian anymore. If you already have one, you should continue to use them. Our recommendation is to use an open module and event-driven architecture, unified namespace. We have another videos about it. We have a huge learning articles about it. If you don't know it, go check it out. So instead of sending all data directly to the historian, so data flow through databases, consider it routing it through a message broker. I'm actually writing an article about it, so I'm not want to mention it here, how the data model could look like. This is like an upcoming blog article. But if you do it to send it through a message broker, you have an immediate benefit because you are suddenly able to use the current landscape of IT of 2023. You're not limited by 90s technology anymore. You can suddenly transmit a much higher number of data tags or data points and leverage the same technologies than a Google, Facebook, TikTok that they can use. And then you can route those data back to historians. Maybe you need to downsample it because they're not able to handle such large amounts of data. But what you can now do is you can integrate new use cases around it. So what comes typically after it? Typically after the unified namespace comes the database. And there are actually two types of databases, and we spent a little bit of time on it because I think it's really helpful and it often gets mixed up. There are OLTP databases and OLAP databases. OLAP databases means online analytical processing, and OLTP means online transactional processing. Starting with OLTP databases, they are optimized for real-time execution of a vast number of simple database transactions. It enables frontline workers behind everyday transactions like banking, e-commerce, hotel reservations. In manufacturing, it would be something like orders, current stock levels. This is stored in an OLTP database, and this is typically an SQL-based database. And the OLAP, the online analytical processing database, is what you typically consider a data lake. It's not designed for daily usage by the frontline workers. It's designed for data scientists. It's designed for knowledge workers who want to take a look at large data volumes, data mining, business intelligence, and they want to apply complex AI algorithms they want to create reports, and these databases are optimized for this. So you have those two types of databases. How we typically do it is after the unified namespace, we put a relational database like Postgres behind it, so that you are able to store OLTP database, that you're able to store relational data. And then you typically often need the time series database, such as timescale.db and InfluxDB. We typically, at the moment, prefer timescale.db because we wrote another blog article about it and have a couple of videos and interviews about it. But in this story, the main reason is it combines a time series database with a Postgres database. It puts it together, which is easier to maintain. What you can then do is export this data, maybe via an API in regular intervals, to put it into an analytical database, so that you can work in daily with one database, but then if you want to conduct large queries over 10, 20, 30 years, you put it into different ones. And when you use, for example, timescale.db, it even allows you to outsource automatically all the data points to S3, so that you can benefit from the cost savings while only increasing the query time a little bit. I wrote a little bit about timescale.db versus InfluxDB, a little bit of the differences. We already wrote a lot about it. But one thing that's new is that they released their new version, the 3.0 version, and they are building up now on the Apache ecosystem, Apache Arrow, Parquet, I don't know how to spell it, Data Fusion. They have now integrated SQL support in the new version. But one crucial concern of us remains, and this new version is the perfect point of it. I mean, they just rewrote their entire database. They even rewrote it in an entire new programming language. Every time you develop something from scratch, of course you might have new features, but you always introduce new errors. And if you have something that's at the core of your infrastructure, we already saw it a couple of years back with InfluxDB 2.0. There are always like these minor unnecessary bugs. We're really not a fan of it. Like, why are they writing it from scratch again? Like, is there maybe a 4.0 version coming? Database is something that you want to throw in, you want to put it into architecture, and it stays there for 10, 20, 30 years. And for this, the Postgres is a relatively good choice because it's super widespread and is already in practice for like 20 years, 20 to 30 years. So you now have the OLTP database, and now you can put a visualization tool like Power BI or Grafana on top of it. Now you have for your data lake, the OLAP database, you can throw some data scientists on it, and everyone is happy. So maybe this type of architecture, maybe let's compare it to the, let's do actual cost comparison to historians. So if you take, for example, Timescale Cloud, the two options, one is to use Timescale.db in the cloud, and one is to host it yourself on a on-premise server. If you use the cloud version, it will cost you, for the same case, around 1K per month, including everything, including backups, no maintenance, no further storage, no compute costs. Everything else is automatically included. And they also have an option, I already talked about, to automatically put it into S3 storage, so that you can even decrease the storage costs, but it doesn't seem to be publicly available because they wrote about it, but you need to contact them to enable it. This might be a little disadvantage. The other alternative, I talked about it, is you can just put it on your own server, but then you need to maintain the server costs, the personnel to maintain it, but you have a higher degree over your data and infrastructure. InfluxDB, they also have like two offerings. One is like the pay-as-you-go service, which is just ridiculously expensive. I wrote to them, and they basically said, yeah, hey, for historians, the dedicated version where you install InfluxDB on your own infrastructure is probably better suited. But and it also has like similar compression and also apparently S3 integration, but it seems to be very new and they don't have any public pricing on it yet. So I don't know. They told me that it's comparable, but and that their features are in there, but I have no option to verify that. They actually offered me to test it, but I don't want to spend too much time on it. I checked the documentation and couldn't find anything there, which means it's still in development, or I would say even it's currently released. Maybe when this video is released, they have more information on that. I think it's a quickly changing topic. Also, let's take a look at compression in this type of architecture, like when you're using timescale. By default, you can enable it, and TimescaleDB will provide you with 94 to 97% lossless compression. If you want to deep dive, you can look into the article here. But if you want to integrate it, like what are the steps to achieve similar compression rates? First one is you need to enable exception reporting, deadbands in the unified namespace. For example, in Node-RED there are deadband nodes, a lot of various methods how you can do it, but with this you can do the first step of the OSIs of pi compression rate, like to reduce the data. Then you can enable data compression and retention. We have a tutorial for that in Timescale how to do it. And then you can additionally apply, it's not the swinging door algorithm. TimescaleDB only offers the largest triangle 3 buckets algorithm. I haven't found any detailed comparisons between those two algorithms. The difference that I know is that the swinging door system actually works in online mode, so it's applied before it's stored into the database, and the largest triangle 3 buckets version of TimescaleDB and a lot of other modern time series databases, they are in offline mode, so it is applied after everything has been stored. So that was basically the article. A lot of information, a lot of facts there, also obviously some opinions of us. So we compared in terms of compression. We found out, hey, does compression really matter? There are more important factors, and if you also want to have compression in open source databases, compression in terms of downsampling, you can very easily do it. So the only reason left to buy the historian is if you just don't care. If you just want to buy something, be done with it. Yes, if you want to move into the modern IT landscape, then probably something that I described here would be better suited. And thank you for the following persons: Rick Bolotter, James Sewell, Michael Bartlett, Bharath Sridhar, I hope I spoke that out correctly, Alyssa Nichols from InfluxDB for available feedback in creating this article. We contact all companies that were mentioned here. TimescaleDB answered us very quickly. InfluxDB answered us very detailed. Canary answered us, but Canary, they applied initially very quick, but they haven't provided us, since the recording of this video, with the feedback. And Aveva, they didn't even talk to us back. We were ignored entirely on this. Yeah, so thank you for listening. I hope it was really useful. Check out, if you are interested more in it, the original article. Check out the other blog articles that we have. We have now a newsletter. So if you don't want to miss out on this type of content, feel free to subscribe there. Join our Discord community, where you can exchange with other experts there. And if you are interested in our commercial products, feel free to contact us. We'll be happy to help you. Thank you.